everyone, today we're going to discuss about the rules of equivalence. So in our next two videos, we're going to have the rules of equivalences and the rules of inferences. These rules are used whenever we prove that a statement is true or false. So we're going to start first with the rules of equivalence. When we talk about the rules of equivalence, these are statements which indicates that this statement is equivalent to the other one. So meaning a statement can be rewritten into another statement following this particular set of rules. So let's see what kind of rules do we have whenever we rewrite a statement. The first one we have is commutative. So this works both for the or and the and, for conjunction and disjunction. P or Q can be rewritten as Q or P. In the same manner, P and Q can be rewritten as Q and P. So you can flip around the two statements. The second rule is the associative. So if we have three statements, and again, associative works for conjunction and disjunction. So if we have three statements, P or Q or R, where you put an emphasis on the P or Q first, you can transfer the parentheses to the other side. It becomes P or the quantity Q or R. The same thing can be said about the conjunction. So the same logic applies for associative. Take note that associative works if both statements have the same operation, or and. But if they are different, like in this scenario, we're going to use distributive, or and, or. We have three statements, P or the statement Q and R. So there's an emphasis on Q and R here. There's a parenthesis. So we will distribute the P on Q and R. So take note of the operation of P or Q and R is P or Q, that's the first statement, and the operation in between, P or R, operation here again. So P or Q and R implies P or Q and P or R. So that's how it works, huh? So the one in the middle is this operation, the second operation. For the first operation will be applied on the first and third. Take note of the pattern, huh? Because this distributive rule is pattern based. The same thing goes if the signs were flipped. P and the statement Q or R, it becomes P and Q or P and R. For the fourth rule, we have the double negation. Not of not P becomes P. Like if a negative is a negative, it becomes positive. It's the same logic. For the contrapositive statement, we have P implies Q if and only if not Q implies not P. So we can rewrite a statement into its contrapositive form. P implies Q. We flip around the antecedent and consequent. We reverse the P and Q and we negate them. So they have the same truth value. P implies Q implies not Q implies not P. So that's the contrapositive. For the next one, we have De Morgan's law. For the De Morgan's law, the idea here is that we get to distribute the not sign. However, if we distribute the not sign, the or symbol becomes the and symbol, and the and symbol becomes the or symbol. Just like when we distribute a sign in a binomial, the negative becomes positive and the positive becomes negative. That's the same logic. So the not of the statement P or Q becomes not P and not Q, while the not of the statement P and Q becomes not P or not Q. We distribute the negative symbol, the negation, but the or becomes and the and becomes or, much like when you distribute a negative in a binomial. For the second one, for the seventh rather, we have the material implication. So for the material implication, we can rewrite a conditional statement into a compound statement. So P implies Q is equivalent to not P or Q. In the same manner, if we have not P or Q, it can be rewritten as P implies Q. For the eighth one, we have the material equivalences, or the material equivalence rather. There's no S. So this one we can write a biconditional statement into a combination of a compound and a conditional statement. So P if and only if Q can be rewritten as P and Q and Q. P implies Q and Q implies P. Remember that the if and only if the biconditional works both ways, diba? P implies Q and Q implies P. So we can separate the P if and only if Q as two conditional statements, P and Q, and P implies Q and Q implies P. And for our last rule, we have the exportation. So we can write P and Q implies R as P implies the statement, Q implies R. So we can write it this way. Or if we have P implies the statement, Q implies R, we can have P and Q implies R. Since if P happens and Q happens, R will happen, right? So we know that if P and Q both happen, R will happen. So it will become true. So that's the rules for equivalences. So let's have an example here. So in this case, let's have it here on the other side of the paper. So example. So our given would be A or not B or C. So that is our given. We would like to prove that A or B implies C. This is what we want to prove. So the Q on knowing what to prove is this symbol. It's the therefore symbol. So let's have a table here. So table, let's have the statement and the reasons. So one unique thing that we're going to do here is we're going to number it accordingly, both the statement and the reason. So we have 1A. Now take note that the given will be rewritten as letters A, B, C, D. But for the statements, we're going to write as 1A, 1B, 1C. Later on in our rules of equivalence, you'll see an example like that. So 1A is this given here. The reason it is given. For statement 2, what we're going to do is we'd like to prove this one. So A or B implies C. So as we can see here, what's group is A or not B. Then the C is separated here. We can move the parenthesis in order to cover the not B or C. So we can have our statement as A or not B or C. We move the parenthesis to cover A or not B into not B or C. So that will be our statement number 2. What we just manipulated is statement 1A. So that is 1A associative. We're going to include this statement here, this number here, to indicate that this is the statement that we just manipulated. For number 3, we now know that not B or C exists here. So we can write not B or C as P implies Q using the material implication. So we can rewrite the statement as A or B implies C. This is 2 material implication. We can do it inside the statement because we are saying that in the rules of equivalences, not B or C has the same truth value as B implies C. So that the material implications tells us that that is true. So we're able to arrive at this statement. So let's have our tombstone here. So tombstone. So this indicates that we are done with our statement. So that's it for proving using the rules of equivalences. In our next video, we're going to prove statement involving the rules of inferences. So I hope you guys learned a lot today. Thank you guys for watching and see you guys in the next video.